Hello PLP geometry students, and welcome to our Unit 1 video number 10 on parallel lines with transversals. Again, I know for a fact, I think it's back in 7th grade, you talked about, maybe 8th grade, you talked about parallel lines. So you know all about these names. I think one they don't talk about, but at least 3 of them they do. So again, I'm just here to refresh your memory, right? That's all I'm here to do. So this is Unit 1, Intro to Geometry. We're almost done, right? And this is our 10th lesson of the series, and this is on parallel lines. Parallel, that double L, right? The symbol for parallel is in the name, right? Parallel lines with transversals. Transversals. Perfect. Okay, so let's define what a parallel or set of parallel lines are. So parallel lines these are two lines. Now this part I don't really care about, but in geometry they want me to say this. In the same plane. In the same plane. And again, basically that just means they're going in the same direction. Okay? So again, that do not intersect. That do not intersect. Okay? Now, this word for in the same plane, that is the word coplanar. So again, these are coplanar lines that do not intersect. Okay. Now, I did suggest if you want to think about it, right? So think about goalposts. So goalposts, both of them are going up, right? So like this, right? So these two lines are parallel because they're going up. Pretend, and again, this is hard for you to say, pretend that one of those goalposts dropped down and was like coming at us, right? So those might not touch, but again, one's going up and one's coming at you. We call that skew. And again, I don't care enough to explain it full out, but if you put your arms straight up like goalposts, and then if you lower one arm and point it towards like your friend sitting across from you, that would be skew. So goalpost up is parallel, arm pointing out, arm pointing up is skew, because they're not in the same plane. All right, but again, don't care. Now, let's talk about what it means to be a transversal, because aside from parallel lines, for all this to work, you have to have a third line called a transversal. Transversal. This transversal is that third line, so it's a line that passes through two lines. Oh, sorry. Can't spell the word passes. Uh-oh. That passes through two lines in the same plane. So again, right, that whole idea of coplanar, in the same plane, at two distinct points. Another word for distinct could be different, at two different points. Okay, so if you want to think it like that. So this is what's going to make our picture so that we can then talk about angle pairs, because from parallel lines and transversals, we get some angle pairs to talk about. Okay, so let's talk about those angle pairs. First up, let me draw the picture, right? So I'll use yellow here. So say I have line L going like this, and line M going like that. I am telling you that L is parallel to M. Okay, so based off of that information, I could put what are called arrows on the lines. And again, I think some of you guys have seen this in your delta math problems, and now we can finally talk about what these arrows mean. So if I put an arrow here and an arrow here, that means those lines are parallel. If I put a second pair of arrows, again, they're still parallel. So make sure they have the same number of arrows. Okay? And now if I draw a third line, I'm going to draw it kind of like, I guess that's fine. It's not supposed to be up and down. Try not to make right angles. I should have made it a little bit more angled, but it's fine. Just don't make right angles, right? This, I'm going to call line T. This will be called my transversal. So T is the transversal. So L is parallel to M. There's your symbolism that you'll see in a sentence. Here's your picture, and T is your transversal. Now, when you have these two parallel lines cut by a transversal, you create 8 angles. There are 4 angles up here where L and T intersect. I'm going to call them just like this. Please be very careful. 1, 2, 3, and 4. And there are 4 angles down here where M and T intersect. 5, 6, 7, and 8. Okay, now, before we talk about the new angle pairs, let's talk about some old ones. So, if you were to block off line M, angles 1 and 3 and angles 2 and 4 are vertical angles from our last video. And if you look at angles 1 and 2, they're a linear pair. 2 and 3, they're a linear pair. 3 and 4, they're a linear pair. 1 and 4, they're a linear pair. So at each intersection, there are relationships among those 4 angles. What we're doing today is we're trying to take an angle from the intersection of L and T and compare it to an angle from the intersection of M and T. So it's not at L, it's not at M, it's using both intersection points, an angle from each one. Okay? So what I'm going to do is I'm going to keep this picture fresh, and I'm going to just keep erasing down here so we can see this picture. Okay, so let's talk about the first pair of angles, which I'm going to call corresponding angles. So these are corresponding. I like to capitalize, sorry, so I'm going to make that a capital T or a capital C. Corresponding angles. Corresponding angles. And I'll use the angle symbol. For corresponding, I like to use the abbreviation CORR, corresponding. So in this picture here, there are 4 pairs of corresponding angles. Now, one thing to keep in mind, and again we'll talk about it in a minute, is that when your lines are parallel, so if your lines are parallel, then your corresponding angles are going to be congruent. And you'll see in a second why. So, angle 1 is going to be corresponding, and in this case congruent to. Now, if you look at angle 1 is in the top left of this intersection up here, right? If I were to take angle 1 and put it in its same location, but down at M, it would go on top of 6. Angle 1 and angle 6 are corresponding. Top left, top left. So again, this is the top left, top left. If I go with angle 2, and if I take angle 2, which is in the top right, and I cut it out and put it down where M and T intersect, it would be angle 5. Angle 3 is in the bottom right. If I cut it out and put it at the bottom intersection, it would go where angle 7 is. Angle 3 and angle 7 are corresponding. And angle 4. If I cut angle 4 out and put it at that bottom intersection, it would go on top of angle 8. So corresponding angles have 4 angle pairs within this picture. It's the only one with 4. Okay. Next, let's see if I can. No, I wish I could. Nope. Okay. Let's talk about what are called alternate interior angles. So I think, again, from 8th grade, from middle school, I believe corresponding angles is something you've talked about. Okay, let's turn to blue. Let's talk about alternate interior angles. So alternate alternate interior angles. Again, we'll abbreviate alt, int. Okay, same thing here, right? For alternate interior angles, if you have lines parallel, then you have alternate interior angles congruent. Okay? Now, notice there are two words here, alternate and interior. So the word alternate has to do with the transversal T. So if I look at this transversal, it's kind of going up and down. So there is a left side and there's a right side. So when we talk about alternate, one angle comes from the left, one comes from the right. When we talk about interior, we're talking about in between the parallel lines. So our lines go like this. So this is the interior in between them. So up here, the interior angles are going to be 3, 4, 5, and 6. This space in here, that's the interior. Okay? So if I look at angle 3, its alternate interior angle, so alternate, its choices are 4 and 6, but it has to be down at the other intersection. Its alternate interior angle is 6. They're going to be congruent. Angles 4 and then angle 5 are also alternate interior angles. They're going to be congruent. So there are your two angle pairs. Okay. Next one here, let's erase that. So we have another alternate, but this time we're going to talk about alternate exterior angles. Right? So hopefully, right, again, part of math is pattern building and just thinking and connecting, right? So if that was alternate interior, then alternate exterior should be kind of similar, but in the exterior, right? So we're going to talk about alternate exterior angles. And again, for alternate exterior angles, we're doing Alt-X for the abbreviation. Again, if your lines are parallel, your alternate exterior angles are congruent. Now, again, alternate means with the transversal, so we're still looking at T, but now the exterior, if you think about your parallel lines going this way, now the exterior is outside of the parallel lines. That space in between there is empty. So this is the exterior and this is the exterior. So now our angles are 1, 2, 7, and 8. So angle 1 is going to be an alternate exterior angle, so it could be 7 or 2, but it has to be down at the other intersection, so it's going to be 7. And angle 2 is going to be congruent to angle 8. Again, only two angle pairs. And last, but certainly not least, and one of the major different angle pairs is called the same side interior angles. So I saved this one last because, again, it has a couple differences that are important to keep in mind. So I'm going to do this here in orange. So now we're going to look at the same side interior angles. Interior angles. And again, I like to do SSINT. Same side interior. This time, if your lines are parallel, then your same side interior angles are supplementary. Big difference here. This time they're going to add to 180. Okay, so keep that in mind. Now again, we're doing same side interior angle. So now this word same side again has to do with the transversal T. So now we want them both to be on the left or both be on the right. And the interior goes back to, okay, if these are my parallel lines, it's in between. So our choices are 3, 4, 5, and 6. If I look at angle 3 is on the same side of T as angle 5. So we should know that the measure of angle 3 plus the measure of angle 5 will equal 180. Same thing with 4 and 6. The measure of angle 4 plus the measure of angle 6 is 180. And there's only two of those. Perfect. So there's all your angle pair types. So I'm going to make a second video, and I'm going to do a couple examples involving solving equations, just to kind of reintroduce how you solve them, because Algebra 1's been a long time ago. Okay? So again, please continue on watching video, this is number 10, so this is going to be 10A, so go ahead and watch 10B next.